Okay, let's continue solving our questions. The next question is, find the discrete time Fourier series coefficients of the signal x of n, plot the magnitude and phase spectrum. Okay, so you're asked to find out the Fourier series coefficients, discrete time Fourier series coefficients of n x of n, which is given by 5 plus sine n pi by 2 plus cos n pi by 4. So you might be remembering when signals like a sine or cosine or complex exponentials are being introduced to find out the Fourier series, the thumb rule is you have to find or you have to adopt the method of inspection. So you might be remembering this. We have done many problems on this. So method of inspection, because your x of t is a sinusoidal signal. Okay. So in the given signal, let us find out what is omega 0 and what is n. What is angular frequency and what is time period. So given signal x of n is equal to 5 plus sine n pi by 2 plus cos n pi by 4. So how will you find out the omega 0 angular frequency of this signal? How is omega 0 find out? It's for we have done it in the first modules. Anyway, let us refresh how we found out the omega 0 of the signal. What we did was omega 0 is equal to HCF of the numerator divided by LCM of the denominator. Okay, I think you might be remembering this. When referring to numerator, I am referring to this thing, the argument of sine and cosine. So in the numerator, we can have pi, this pi and this pi comma pi, divided by what is the denominator? LCM of denominator. The denominator is 2 comma 4. So 2 comma 4. What is HCF of pi and pi? It is pi itself. Divided by LCM of 2 and 4, it is 4. Okay. So pi by 4 is the omega 0 or angular frequency. And since pi by 4 is the angular frequency, then n equal to 2 pi by omega 0, which is 2 pi by 4 is equal to 8. So 8 samples. Alright. So for some specific reasons, we have already found out omega 0 as pi by 4 and n equal to 8. Right. Now, and finally, what is discrete time Fourier series? How will you find out discrete time Fourier series coefficients? You can have discrete time Fourier series coefficient using the synthesis equation. X of n is equal to sigma over k equal to 0 to n minus 1. Okay, x of k is the capital X of k is the Fourier series coefficients into e raised to jk omega 0 n. Okay, this is the expression for general expression for discrete time Fourier series coefficients. How x signal x of n can be represented in terms of discrete time Fourier series coefficients. And since we have found out for this particular signal that omega 0 is pi by 4, I can always substitute pi by 4 for omega 0 in this expression. Okay, so I am doing that also. That implies x of n is equal to sigma over k equal to 0 to n minus 1 x of k into e raised to j into k into omega 0 is, we have found it out as pi by 4 into n for this particular signal. Okay, so let me now express this as equation number 1. Okay, so this is my takeaway from this equation or the DTFS equation. Okay, so I have semi-generalized our x of n, the general discrete time Fourier series equation, except that I've given omega 0 as pi by 4 pertaining to the original signal. Okay, now let me come back to our signal. X of n is equal to, we are given our question as sine 5 plus sine n pi by 2 plus cos n pi by 4. Okay, now I can logically do what? I can find a way to express the signal in terms of complex exponential, because in equation number 1 x of n is expressed in terms of complex exponential signals. So I am trying my given signal to express in terms of complex exponentials. How can we do that? It is very simple. It is 5 into e raised to j0 plus, how can you convert sine n pi by 2? Sine is e raised to j theta, right? E raised to j n pi by 2 minus e raised to minus j theta. E raised to minus j n pi by 2 whole divided by 2j. Remember, 2j is important. Plus, now the next term is cos n pi by 4. Similarly, we can write cos n pi by 4 as e raised to j theta. That means e raised to j n pi by 4 plus e raised to minus j n theta minus j theta. That's e raised to minus j n pi by 4 whole divided by 2. Okay, so a bit more relaxed. I think 5 e raised to j 0 plus 1 by 2j e raised to j n pi by 2 minus e raised to minus 1 by 2j e raised to minus j n pi by 2 plus 1 by 2 e raised to j n pi by 4 plus 1 by 2 e raised to minus j n pi by 4. I have expanded all the terms and read this equation. Okay, now what I can do is, now I am writing the above equation in a way that resembles equation number 1. Okay, I'm going to write this equation itself, but in a way that resembles equation number 1. Let us see how can I do that. This is equal to, first term is 5 e raised to j0. I'm writing it as 5 e raised to j into 0 into pi by 4 n. Is there any problem? Absolutely no problem. This is same as 5 e raised to j0, which is this term. So these two terms are same. No problem. Plus the next term is 1 by 2j into, instead of e raised to j n pi by 2, let me write it as e raised to j into 2 into pi by 4 n. Is there any difference? Not at all, because e raised to j into 2 into pi by 4 n is same as e raised to j into pi by 2 n. So this term and this term is exactly same. No problem. I've just modified it like this. Okay, we will see why I have written like that. We will see that. Minus 1 by 2j into, my next term is e raised to minus j n pi by 2, but I am writing it as e raised to minus, or e raised to plus j into minus 2 into pi by 4 into n. If you look very closely, that these two terms are exactly the same, because e raised to j into minus 2 pi by 4 is e raised to minus j pi by 2 into n. So this term is same as this term. And now the last two terms, 1 by 2 into, I'm going to write e raised to j n pi by 4 as, it's very simple, e raised to j into, okay, e raised to j into 1 into pi by 4 n, right? These two terms are same. Plus the last term is e raised to, okay, e raised to plus j into minus 1 into pi by 4 into n. Okay. Now we will see why I have written like this, because you can see that in equation number 1, in our original equation, there is an exponential term and there is x of k, and this product is being summed to 0 to n minus 1. So in our last equation also we can see there is a e raised to term and multiplied by some constant, and this is summed to many terms, right? So this is it, because you know whatever you find with the n is the signal. Okay, e raised to jk pi by 4 into n, this portion is the signal, because n is the variable, x of n, we say it as x of n, which is a function of n. So this portion is the signal, and whatever we can find as the coefficient of the signal will be x of k. That is very clear from this equation. Whatever be the coefficient of e raised to j k pi by 4 n will be x of k. Okay, x of k is Fourier series coefficients which we need. That's what we have to record. Okay, so similar to that, in this equation there is a signal term, right? There is a signal term and the coefficient of that signal will be x of k. Here is also a signal term, the coefficient will be x of k. Here it is a signal term, coefficient is minus 1 by 2j is x of k, and like that, right? So we have found out what x of k is. What x of k is? X of k is nothing but the coefficient of the signal, that is 5 or 1 by 2j or minus 1 by 2j, 1 by 2 and 1 by 2. These are x of k's. But how will you find out the specific value of k? That is very simple, because you have to compare every term for that. Let me take this term. Here the signal is e raised to j0 pi by 4 n, as it contains n there. Okay, it's the only term or only a factor which contains the variable. So e raised to j0 pi by 4 n is the signal. Now compare this signal with this signal, e raised to jk pi by 4 n, e raised to jk pi by 4 n, e raised to j0 pi by 4 n. What can you infer? Nothing but k equal to 0. Okay, so x of k equal to 5 for k equal to 0. Okay, x of k equal to 5, right? I can write it as by inspector or by comparing with equation number 1. By comparing with equation number 1, I can arrive at the following conclusions. X of k equal to 5 at k equal to 0. Okay, or in other words, I can write it as x of 0 equal to 5, right? X of k equal to 5 at k equal to 0 means x of 0 equal to 5. So I can write it as x of capital X of 0 equal to 5. That is our DC component. Okay, now when you come to the next term, you have to compare that x of k is 1 by 2j. Whatever be the coefficient of the signal, that is 1 by 2j is x of k. And what is k? E raised to jk pi by 4n, e raised to j2 pi by 4n, right? E raised to jk pi by 4n, e raised to j2 pi by 4n. So clearly k equal to 2. So I can write x of 2 is equal to 1 by 2j. Okay, x of 2 equal to 1 by 2j. And 1 by 2j means it is actually equal to minus j by 2, right? You know how it occurs, right? Minus j by 2, because 1 by 2j, I can multiply j and j on both numerator and denominator, and j into j is minus 1, right? So this is j by minus 2, or this is equal to minus j by 2. Okay, so minus j by 2 means it is I can write it as it is 1 by 2 into, right, minus j by 2, the magnitude is 1 by 2, right? And what is minus j? Minus j means you are multiplying a vector by, or a scalar by minus j, means you are rotating it by minus 90 degree, right? Suppose this is a scalar always lies in 0 degree. So if you are multiplying it minus j with minus j, means you are rotating it by minus 90 degree. Okay, so I can write it as it is magnitude is 1 by 2 and angle is phase is minus 90 degree. Okay, phase is minus 90 degree. So that is x of 2. X of 2 is 1 by 2 angle minus 90 degree. Okay, so we have finished with first two terms, and pertaining to the third term, what is x of k? X of k is minus 1 by 2j, and what is k? K is minus 2, right? K is minus 2. So I can write it as x of minus 2 is equal to minus 1 by 2j. You cannot forget this minus sign. Okay, so minus 1 by 2j, that is equal to 1 by 2 angle. What is the angle? The magnitude is 1 by 2 and the phase is minus 1 by j. Minus 1 by j means it is plus j. Okay, you multiply j on both numerator and denominator, you will get j. So multiplying with j means, what does that mean? if it's a scalar, and multiplication by j means you are rotating it by plus 90 degree. So angle plus 90 degree. So that is x of minus 2. 1 by 2 angle plus 90 degree. Okay, now let us check this term. Here x of k is 1 by 2 and k is 1. So I can write x of 1 is equal to 1 by 2. That is equal to 1 by 2 angle 0 degree. Alright. And from the last term you can clearly understand that x of k is 1 by 2 and k is minus 1. So x of minus 1 is equal to 1 by 2, and there is no j term, so angle is 0 degree. X of minus 1 is 1 by 2 angle 0 degree. And so we have found out all the Fourier series coefficients. X of 0 equal to 5, that means it is equal to 5 angle 0 degree. You know that it's a scalar value. Okay, so x of 0, x of 2, which is half angle minus 10 degree, x of minus 2, x of 1, and x of minus 1. Now the question clearly asks us to find or plot the magnitude and phase response. So let us do the plot on magnitude and phase response quickly. Okay, so I'm going to find out the magnitude plot, only the magnitude versus k. Right, so what is x of 0 at k equal to 0? At k equal to 0, x of 0 equal to 5. Okay, so k equal to 0, x of 0 equal to 5. Okay, what is x of 1? X of 1 is 0. There is no x of 1 here, so x of 1 is 0. What is x of 2? X of 2, the magnitude of x of 2 is 1 by 2. Okay, so the magnitude of x of 2 is 1 by 2. You can have 1 by 2 here. X of 3 is 0. X of 4 is 0. Then x of 1 is there. Okay, okay. X of 1 is there. X of 1 is half angle 0 degree. So at x of 1, we have a magnitude half. Okay. Right. Then no other k values are there with the positive or non-zero coefficients. Right. And now we can have x of minus 1. What is x of minus 1? X of minus 1 is magnitude is half. Magnitude is half. So we can have magnitude half here. Then x of minus 2. X of minus 2 is also having magnitude 1 by 2. So x of minus 2 is also having magnitude 1 by 2. Okay. Now there is no any other x of k values. Right. Fine. Now there is something very important, because the plot is not over here. You may seem that we have plotted x of 0 equal to 5, x of 2 as half, x of minus 2 magnitude as 1 by 2, x of 1 magnitude as 1 by 2, and x of minus 1 as 1 by 2. Total there are 1, 2, 3, 4, 5 plots, right? 1, 2, 3, 4, 5 plots. You may think that the plot is over, but it is not over, because we are dealing with discrete time Fourier series. Discrete time Fourier series, and discrete time Fourier series in frequency domain is periodic. That is a very important result. It is periodic. That means whatever we have plotted here, this repeats at regular intervals. Okay, it repeats at a period which is equal to the time period of the signal, and we have initially calculated the time period of the signal as n equal to 8, right? So this plot repeats itself after every n equal to 8 samples. Okay, every n equal to 8 sample, this thing repeats. So let us take a repetition interval. Normally for error-free plot, we take the sample or one period not from 0 to 7, right? You can take it from 0 to 7. 0 to 7 means there are 8 samples. But for error-free plotting, always you take from negative to positive values, right? You take 8 samples, but from negative to positive values. For example, I can take n equal to, or k equal to -3 to 4, right? K equal to -3 to 4 means there are 4 minus 3 plus 1 is 8 samples, right? There will be 8 samples. So from -3 to 4, including 4, this is one complete time period, one complete period. So I can mark it in another ink, right? This is one time period. So after that, this repeats, right? After that, this repeats. So that means -3 is the starting of the interval, starting of this time period. So 5 will be the starting of the next period. So whatever the values in -3 will repeat at 5, right? So 3 has no any values, so 5 should not have any value. Okay, now -2 has 1/2, so 6 will be having 1/2. Okay, so 6 will be having 1/2. 6 will be having 1/2. Okay, 7 also will be having 1/2 because -1 repeats to 7. Okay, so 7 will be having 1/2 because the period is 8. Okay, then 8 will be having 5. Okay, I can rub this for clarity. Okay, 8 will be having 5, 9 will be having 1/2, and so on, right? Okay, it repeats. Similarly for negative time also. In negative time, you can see that -4 is the starting of or end of this time period. Here 4 is the end of the time period. Okay, so 4 and 3 has no values. That means -4 and minus will be having no values. Okay, 2 will be having half. That means 6 will be having 1/2. So 6 will be having 1/2. 7 will be having 1/2. -8 will be having 5, and it goes on. Okay, so whatever we have found out as x of k repeats at n equal to 8. Okay, so that is the peculiarity of the DTFS plot. Okay, now this is the magnitude plot. This was the magnitude plot. Now let us draw the frequency plot, I mean phase plot also. Phase plot is also required. So that's very simple. Phase plot also is periodic with n equal to 8. Okay, so I can do it roughly. Okay, this is angle of x of k. What is angle of x of 0? It is 0 degree. Okay, it is 0 degree. Then what is angle of x of 1? Angle of x of 1 is here it is 0 degree. So x of 1 is also 0 degree. What is angle of x of 2? X of 2 is -90 degree. So here we can have -90 degree. -90 degree. Okay. Now what is angle of x of 3? There is no x of 3. There is no x of 4. Okay. And in negative side, what is angle of x of -1? Angle of x of -1 is 0 degree. Okay. What is angle of x of -2? That is +90 degree. X of -2 is the angle is +90 degree. So this is +90 degree. X of -3 is not there. Okay. So from -3 to +4, I have got these much values, only 2 angles. So this will repeat in the next time period to positive and negative sides. Okay, so this time period starts at -3. So it 5 also 0 degree, then for minus 2 we can have 90 degree, that repeats to 6. So at 6 we can have 90 degree. Then for minus 1 it repeats to 0, 0, 0, and in 10 we can have minus 90 degree. Okay, and it repeats. Here also 4 we have 0, so here 0, 3 will be 0, in minus 6 will be having minus 90 degree, because this value repeats at minus 6, right? 2 minus 8 is the, right, 8 equal to n equal to 8 is the period. Okay, so you can always do 2 minus 8, that means minus 6. So this sample repeats at 2 minus 8, but that means minus 6. We can have another example at minus 2 90 degree, so minus 2 plus 8, that means 6 you can have 90 degree. Okay, so that repeats at every n equal to 8 sample. Okay, so this is the phase plot. Okay, our next question is, find all possible time domain signals for the Z transform given x of z equal to 1 by 1 minus 1 by 1 minus 1 by 6 z inverse minus 1 by 6 z inverse 2. Okay, so the question clearly tells us to find out the inverse inverse z transform for this given z transform. So while finding out the inverse z transform, there are many possibilities, right? Many possibilities of time domain signals. On what basis we can classify these possibilities? It is based on the ROC, the different possible ROCs. We can have different possible time domain signals. Let us see how it can happen. So to find out the inverse transform, we have to write this this polynomial into factorized form. How can we write that? This is equal to 1 minus okay, so there are two factors whose sum is minus 1 by 6 and product is also minus 1 by 6. What will be those numbers? That can be 1 by 2 and 1 by 3, right? 1 by 2 and 1 by 3, or minus 1 by 2 and plus 1 by 3. The product will be minus 1 by 6. The product is minus 1 by 6. Okay, and what is the sum? Minus 1 by 2 plus 1 by 3 will give you minus 1 by 2 plus 1 by 3 will give you minus 1 by 6, right? Okay, so minus 1 by 2 and 1 by 3 are our factors. So 1 minus 1 by 2 z inverse into 1 plus 1 by 3 z inverse will give you 1 minus 1 by 6 z inverse minus 1 by 6 z inverse 2. Okay, so we have factorized this in this polynomial into factors. Now it is very simple. We can have the partial fraction expansion to find out what this is. A by 1 minus half z inverse plus b by 1 plus 1 by 3 z inverse. Okay, now what is A? A is, you have to take 1 minus half z inverse, multiply with this main function, okay, and evaluate it at z inverse equal to 2. Z inverse equal to 2 means z inverse equal to 2 makes this denominator 0. Okay, so A equal to 1 minus 1 plus 1 by 3 z inverse at z inverse equal to 2. Right, z inverse equal to 2 is the only number which makes the denominator 0. So this is equal to 1 by 1 plus 1 by 3 into z inverse is 2 by 3. That is equal to this is 3 by 5. Okay, so A equal to 3 by 5. And similarly, what is B? B is equal to, you take the denominator of B, multiply it with the main transform function, then put z inverse equal to minus 3, right? Z inverse equal to minus 3 will make this denominator 0. Okay, so your multiplication means 1 by 1 minus half z inverse will remain, 1 plus 1 by 3 z inverse will cancel, evaluated at z inverse equal to minus 3. Okay, that is equal to 1 by 1 minus or 1 plus 3 by 2, which is equal to 2 by 5. So b equal to 2 by 5. So I can write x of z is equal to 1 by 1 minus half z inverse into 1 plus 1 by 3 z inverse is equal to a by 1 minus half z inverse. A is 3 by 5. So 3 by 5 into 1 minus 1 by 1 minus 1 by 2 z inverse plus b is 2 by 5. 2 by 5 into 1 by 1 plus 1 by 3 z inverse. Okay. Now what we have to do is we have to find out x of n, or the inverse z transform. And for finding out the inverse transform to obtain x of n, we have 4 cases. And to be precise, there are 3 valid cases and 1 invalid case. Let us see how it happens. Let me take that. The first cases, you have to be very attentive now. The first cases, both the signals corresponding to both the poles are right-sided. I can write it as both signals corresponding to both poles, right? Both poles are right-sided. This is one possibility. Actually, what are the poles here? Here the pole we have two terms and 2 poles corresponding to the 2 terms. And what is the first pole? Z is equal to 1 by 2, right? From this term, z equal to 1 by 2 is the first pole, and from this term, z equal to minus 1 by 3 is the next pole. Okay, so associated with this pole, you will be getting one time domain signal. Associated with this pole, you will getting the next time domain signal, and the total x of n will be the sum of this signal and this signal. Okay, this signal means the inverse transform corresponding to this signal and the inverse transform corresponding to this signal. Okay, and what about ROC? You will be having an ROC for this Z transform and another ROC for this transform. And what is the total ROC of total x of z? That will be the intersection of the individual ROCs. We have studied that. It's the intersection of individual ROCs. So let us see what happens to the ROCs if both signals corresponding to both poles are right-sided. Okay, now listen. I have plotted 3 z-plane plots where the first plot corresponds to the ROC for this term alone. This plot corresponds to the ROC of the second term alone, and the third plot will correspond to the intersection of both first term and second term, or in other words, this plot will be the ROC of the entire transfer function. Okay, so as according to our assumption, both signals correspond to both poles are right-sided. What will be the ROC of the first plot? ROC of first plot. That means in this plot, the ROC should be right-sided, right? Okay, this is 1 by 3 and this is 1 by 3, this is minus 1 by 3, this is 1 by 2, this is minus 1 by 2, this is 1 by 3, this is 1 by 2, okay, minus 1 by 3, minus 1 by 2, okay. And now if this signal corresponding to this pole is right-sided, then the Z transform ROC will be outside to the circle, okay, outside to this circle corresponding to this pole. So it will be something like this. This will be the ROC of the shaded portion indicates the ROC of this pole, okay, because the signal corresponding to this pole is right-sided. Similarly, when we consider this pole, the signal corresponding to this pole is right-sided. Again, it should be like this, outer to the circle corresponding to this pole, or mod z greater than half. I can always express this ROC as, this ROC is mod Z greater than 1 by 3, and this ROC as mod Z greater than half, because the signals are right sided. Now listen carefully, and what will be the intersection of this ROC and this ROC? The common area between this ROC and this ROC will be mod Z greater than half, right? Mod Z greater than half. This ROC itself will be the intersection of both of these ROCs. Okay, that's purely logical. So I can mark the ROC as this thing, and there mod Z greater than half will be the ROC. Okay, mod Z greater than half will be the ROC of the enter signal. So what will be the time domain signal? Therefore, both signals are right sided, means we can straight away write it as 3 by 5 into what is the inverse transform of 1 by 1 minus half the inverse? It is half raised to n u of n plus 2 by 5 into inverse transform of 1 by 1 plus 1 by 3 z inverse is minus 1 by 3 raised to n u of n. So this is the answer to the first possibility. First possibility, both signals corresponding to both poles are right sided, so this will be the inverse transform. So this is one answer. Now I can have a second possibility. Both signal corresponding to both poles are left sided. So this plot is for the pole z equal to 1 by 3. This is for the pole z equal to 1 by 2, and this is for the intersection. Okay, so in this case, if both signals are left sided, you can clearly say that the ROC will be inwards to the circle, right? So left sided signal will be having an ROC inner to the circle. So here also, if this term also contributes to a left sided signal, then its ROC should be like this. Okay, now you have to think that what will be the intersection of these two ROCs, this ROC and this ROC. What will be the intersection? Intersection will be this, the ROC itself, right? This ROC I can write as mod z less than 1 by 3. This is mod z less than 1 by 2. So the intersection will be mod z less than 1 by 3 itself. So I can express it like this. Okay. So this is mod z less than 1 by 3. So what will be the time domain signal? Therefore x of n will be equal to, if it is a time domain, I mean left sided, we have to put a minus sign, minus 3 by 5 into half raised to n. There is no change for half raised to n, or no change for this pole, but u of minus n minus 1 will be added because it is a left side signal. Okay, plus the next signal is minus 2 by 5 into minus 1 by 3 raised to n. There is no change for minus 1 by 3 raised to n, but u of n changes to u of minus n minus 1. Okay, so this is the inverse transform when both the terms are both the signals corresponding to both poles are left sided. Okay, so this is the second answer. Okay, now the third possibility is the signal corresponding to the pole z equal to minus 1 by 3 is right sided, but the signal corresponding to the pole z equal to 1 by 2 is left sided. That is another possibility. In the first possibility, both the signals were right sided. In the second possibility, both the signals were left sided. But in this possibility, signal corresponding to z equal to minus 1 by 3 is right sided, but the signal corresponding to z equal to half is left sided. Both right sided and left sided signal. Okay, so now we have to plot very carefully that if at all the signal corresponding to this pole is right sided, then for this plot the ROC should be outer to the circle, right? Outwards to the circle. So I can draw like this, outer to this circle, because the signal is right-sided. Right-sided means outer to the circle. Okay. Now, the pole corresponding to, for this pole, the signal corresponding to this pole is left-sided. That means for this plot, the ROC should be inner to the circle. Okay. So since the signal is left-sided corresponding to the pole z equal to half, for this plot, this individual plot, ROC will be inwards to the circle bounded by the pole. Okay, so this is the ROC of this term. Mod z less than half. This is mod z greater than 1 by 3. Now, for the total signal, total term, what is the intersection of these two ROCs? What will be the intersection? The intersection will be mod z greater than 1 by 3 but mod z less than half. That means this circular strip. Okay, this circular strip will be the intersection. We can write it as 1 by 3 less than mod z less than half. This is the intersection. Okay, so this is the ROC, total ROC. And what will be the corresponding time domain signal? Therefore, x of n is equal to, the signal corresponding to this pole is right-sided. Okay, this pole is right-sided, but signal corresponding to this pole is left-sided. So since it is left-sided, we have to put a minus sign. So minus, what will happen? Okay, minus 3 by 5 into half raised to n. There is no change to half raised to n, but you have to add u of minus n minus 1 because the signal is left-sided. Okay, plus this, now the signal corresponding to this pole is right-sided, so you have to write it in normal form. 2 by 5 plus 2 by 5 into minus 1 by 3 to the power n into u of n because the signal is right-sided. Okay, so this is the third answer. Okay, so these were the three valid possibilities. Now there is one more possibility which is invalid, and I will show you how it is, why it is invalid. The possibility is the signal corresponding to the pole z equal to minus 1 by 3 is left-sided, and the signal corresponding to the pole z equal to 1 by 2 is right-sided. This is just the opposite to the previous case. Let me show you how it is invalid. So if the signal corresponding to z equal to minus 1 by 3 is left-sided, then the ROC should be like that, like this, right? Left-sided signal means inner to the circle corresponding to this pole z equal to 1 by 3. And if signal corresponding to pole z equal to half is right-sided, then you must get an ROC like this. Okay, because this is a plot for pole z equal to half, and since the signal is assumed to be right-sided, the ROC will be outer to the circle, corresponding to this pole half. Okay, so this is mod z less than 1 by 3 and this is mod z greater than 1 by 2. Now, what is the intersection? What is the intersection to this ROC and this ROC? This is mod z less than 1 by 3 and this is mod z greater than half. Is there any intersection? The answer is a big no. There is no intersection. Okay, no intersection because one plot is like this for the first case and second case it is like this. So the ROC, individual ROC will never intersect. That results in a very important result, that the Z transform for such a case will never exist. Z transform will never exist if we assume that the signal corresponding to this pole is left-sided and z equal to half is right-sided. So this is how we can say this is an invalid condition, invalid situation. Okay, so the first three answers are valid and this case is invalid. So that completes the answer to this question.